Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center, and this video series we're going to be exploring each of the planets in our solar system. We're going to be discovering what it would be like to discover our gravity, our weights, on each one of the planet's surfaces. So to do that, I encourage you to grab your pen or pencil, your lab journal, and come along with me. And we're going to discover facts about each planet and do a little math along the way. So let's go exploring. We have now reached the section of our solar system where we get to explore the ice giants, starting first with Uranus. Now, some neat facts about Uranus. One is, if you're a literary fan, especially classic literature and Shakespeare, all of the moons of Uranus are named after characters in Shakespearean plays. So really fun fact there, so you can use that for trivia. Also, its poles are extremely tilted. On Earth, we have an axial tilt of our planet that allows us to have seasonal changes, winter, spring, summer, and fall, which all the other planets have various tilts as well and experience seasons. But Uranus's tilt is quite extreme, to the point where you have the rings in a north-south orientation. So extreme axial tilt of the planet. One of the coolest things about the planet Uranus, all of the other planets are named after Greco-Roman gods and goddesses. When Uranus was first discovered in 1781, it was to be named in honor of the king of Great Britain, of England, which at that time was King George II. So you had this new discovery, and they were naming this new planet George. So George in the Astronomical Society sector, and it didn't just flow, even though it was a great honor to be named after the king. But they decided it's best to stick with the flow of things and stick with the fact that it needs to be among the pantheon of Greco-Roman gods. So they went with Uranus, which was a great father figure in that Greco-Roman. So father figure in kingly and patriarch type setting, so it still kept its patriarch type name. And the image that you see, this light bluish green color with its extreme cloud cover of methane, is very much, we have not explored Uranus as much as we could, so hopefully there will be future NASA missions. Voyager 2 is the only spacecraft that has flown by and taken photographs and data of it, but that was a real quick flyby back in the 70s. So here's hoping we can find a little bit more information about planet Uranus in years to come. So let's calculate what our weight would be on planet Uranus. So doing the math from before, we calculated that our mass on Earth that does not change is equal to 100. We're solving for weight, which I have the variable x here. X equals the mass of 100 times the surface gravity of Uranus is 0.89, and due to the gaseous composition of the planet, it is that number, a little bit lower than the other larger planets. And with that, we do 100 times 0.89, move the decimal point over, and we would equal 89 newtons or pounds if our mass on Earth was 100. Now for our second gas giant, we have Neptune. As well as Neptune is our last official planet in our solar system. We have the bluish color of Neptune, that it's known for that watery world, which Neptune in Greco-Roman mythology is the god of the ocean. So aptly named for the ocean blue planet. It has no liquid water like we would have on Earth, but it does have a thick atmosphere of methane. In a very active atmosphere, and like Jupiter, it has a great spot. But unlike it being red like Jupiter's, it's a great blue spot that swirls and twirls all over the surface and has been there for many, many years. Another great thing about Neptune, with that atmosphere and that thick atmosphere and active atmosphere, it has the strongest winds in the entire solar system. And with that, those winds can reach 1,200 miles per hour or 600 meters per second. Really strong and really fast winds, creating that wildly fast-moving blue spot. Now, what would our weight be on Neptune if we visited? So what we're going to do, we've already calculated our mass is what we would be from planet Earth before we traveled out to our solar system tour. And we calculated that out to be 100. So we're solving for weight. So we have x here. X equals mass of 100 times the surface gravity of Neptune is 1.12. So we're going to do the math where we do 100 times 1.12. Move that decimal place over, and we would weigh 112 newtons or pounds on the surface of Neptune. And remember, no matter how far you explore, no matter how much you discover, know that you are important, and that no matter where you are, at whatever time, science never stops.